10-4 is on dividing. It's got its own little goal because it is the most challenging of the operations, okay? So because there are multiple ways to do it, and sometimes one way is longer than the other way, I typed up what I think is kind of a mental process to go through in doing these, okay? Now, I will say that if it's not quite clicking yet today, you know, bear with it. We'll get there. Okay, we're going to spend, again, the whole next Tuesday, not next Tuesday, the following Tuesday, working on this again, okay? It can be that kind of a challenge, okay? So in order, I'm going to ask myself these questions as I do one of the problems. First, I'm going to see if they're perfect squares, because if everything's perfect squares, unfortunately, it doesn't happen a lot, but then just take the square roots. That's the easiest way, okay? Second, and this is the part that people miss, they forget to do the step 2. And this is across the board. This is my advanced algebra class. This would be my, I don't have an algebra 2 class this year, but I have before, that they forget step 2. Because doing step 2 can make it, or not doing step 2 can make it the hard way. Okay, so that's the part I'm really going to talk about as we go through these. 3 is the simplify by breaking it up. That's kind of like what you just did on those assessments you got back. You know, make 12 4 times 3. Break it up. So reduce and break it up are two different things. Okay? And then lastly, I'm going to teach you a new process called rationalizing the denominator. You cannot leave a radical in the denominator. Okay? There cannot be a radical symbol in the denominator of a fraction. And if there is, you have to rationalize it. Okay? So that's a process I'll show you. And again, that's a process that can be very complicated. And as you will build on that in another class. We're going to keep it on the real basic one, but we're still going to teach that to you. Okay, so first question. Square root 16 over 25. So I'm going to mentally, out loud, go through those series of questions. Okay, so do they all have perfect squares? Yes, they do. So take the square roots. The square root of 16 is 4. The square root of 25 is 5. That fraction is in its simplest form, so I can go no further. I'm done. The negative square root of 9 over 100. So my answer is going to be negative. That's all the negative signs there. Do I have perfect squares? Yes, I do. The square root of 9 is 3, and the square root of 100 is 10. That's as simple as that question goes. I want to point out in this next one how it's written differently. So this one is written as one fraction with one radical, and here we have one fraction with two radicals. These mean the same thing. It wouldn't matter how you write this. The square root of 16/25 would be the same thing as saying the square root of 16 over the square root of 25. So whether it's written as one radical or two radicals, it means the same thing. Okay? So, going through my questions. Do they have perfect squares? Yes. The square root of 1 is 1. The square root of 4 is 2. Okay, so let's start getting more complicated. Square root of 18 over 2. Does this have perfect squares? No. Can I reduce the fraction? Yes. So by reducing, I'm not breaking it up, I'm reducing. I'm taking 18 divided by 2, which is 9. When you reduce the fraction, it's still under the radical. We have not square rooted, we've only reduced. So I get the square root of 9, which nicely gives us a perfect square. The square root of 9 is 3. Jordan, what was your question?
I thought you said that we couldn't have a radical in the denominator.
You can't, but I just got rid of it when I divided.
What about, I mean, the third question?
You can't leave an answer of the radical in the denominator. I square rooted, so my radical's gone.
So the answer is 3, or do you have
The answer is 3. You'll see what I mean by that in a second. I haven't got to that point yet,
What about,
where
like,
I've left it.
So the answer will never have a radical around it, the final answer.
No, that's not true. Just watch. All right, the square root of 8x over the square root of 2x. Do these have perfect squares? No. Can I reduce this fraction? Yes. 2 cancels completely, goes into 8 4 times. My x's are completely gone. X over x is gone, leaving me the square root of 4. And that is a perfect square. The square root of 4 is 2.
And so how do you get that again?
So I reduced 8 divided by 2
Oh.
is 4. And then my x over x equals 1, so that just cancels out, leaving you with just the 4 under the radical. Okay, do I have perfect squares? No. Can I reduce this? Yes. So 8 divides into 72 9 times. And what do I get when I reduce these x's? What do I get when I reduce those x's? Braden?
X squared.
X squared. Would that x squared be in the numerator or the denominator? Did you say, when you answered my question, did you say something over x squared? No, you just said x squared, which would indicate that you're in your numerator. Why is it in the numerator? Why is it in the numerator? Hannah?
Because x to the 5th is bigger.
Because x to the 5th is bigger. Because I think I'm going to hit someone that it's going to end up in the denominator. So I'm taking my 5 minus 3 is 2. We've used that before. We've used that goal before. And then since this was my bigger power, that's why they're up top. Okay? I think we're going to hit one where it ends up on the bottom. So I wanted to make sure I talk about that. Okay, so we've reduced it, which now I can square root. The square root of 9 is 3. And x squared is a perfect square because it's even. 2 divided by 2 is 1. Okay, questions so far? Yes?
On the one right there, like that.
Yeah?
Yeah. Could you just divide by 2 on that one too?
Divide what by 2?
Like, you know how we did on the 18 over 2, we divided it by 2 and got like 9?
That's
Could
what I
you,
did. 8 divided by 2 is 4.
oh,
And here I took 72 divided by 8. It's 9.
never mind.
Okay, so all right, so my next question. Do I have perfect squares? No. Can I reduce this? Yes. So this is where, go to your calculator. So that you, and I know some of you are going to do this by hand or brain or whatever, but I want to show you how you can use your calculator first. So if you want to use your calculator, you can. Okay, so take 27 divided by 75, and you're going to get a decimal. And then go to your function 4. Your green y, green y equals, or alpha, is it alpha? Is it green? Okay. And then number 4 is how you convert that fraction to a, or decimal to a fraction. And you should get 9/25.
Yes.
Okay? So your calculator just reduced the fraction for you. Okay, so 27 divided by 75, it's going to give you a decimal, but then you can go to your function, alpha key, alpha, y equals, and number 4 is reducing that for you then.
So how do you do it again?
27 divided by 75. And you're going to get a decimal. And then you go to your green button, and then y equals, alpha y equals, and then option 4 makes the conversion for you.
F4?
No, green button, y equals.
Oh.
And then option number 4 converts a fraction to a decimal or a decimal to a fraction. And you should get 9/25. Great.
It's divided by 3.
By 3?
Yeah.
Yeah. That's what I mean. You can do this by hand. I just wanted to make sure people could see how they could also reduce on a calculator. Yeah.
So I pressed alpha y equals I on fraction went down to
Number 4.
number 4. Okay. Press enter.
Mhm.
It won't. It doesn't do anything. Or you can just press the number 4.
And enter again.
Oh.
So you can divide them by
I just reduced them both by 3. I'm just reducing the fraction. I'm not doing any square roots yet. Yes?
How come, like, whenever we reduced it, how can you leave it as different, like, radicals?
Because remember I said up here, and it doesn't matter if it's written as 1 or 2, that it means the same thing.
Okay, so you could write it either way?
Yeah.
Okay.
You can write a fraction as 1 radical or 2 radicals. It means the same thing. When you reduce it, it's still under the radical. Now I can square root 3/5. So again, you can reduce that by hand. You don't have to use your calculator. You can just reduce it. They both divide by 3 and I get 9/25. Okay. All right, my next one. Do I have perfect squares? No. Can I reduce this? Yes. So my 3 is going to cancel, going to 25. I don't know why I said 25. It goes into 15 5 times in the numerator. And then my x's are going to reduce and leave me x to the 4th in the denominator. Very good. I knew I was going to get one of those. So my 5, take away 1, leaves me 4, but in the bottom, in the denominator, because that one's bigger. And then my square root 5, I can't do anything with square root 5. It's not a square. It does not have a square factor, so it's going to stay right there. But in my denominator, the square root of x to the 4th, 4 divided by 2 is 2. All right, some questions, because I'm going to start with the rationalizing here. Then we kind of start mixing it up.
does it get harder?
It's just a whole new, it's a new concept. Okay. All right, so do I have perfect squares? I'm going through that process now. No. Can I reduce this fraction? 7/5 does not reduce. Could I break it up? I haven't even got to that third question. Could I break it up? So 7 does not break up. 5 does not break up. Neither of those have square factors. Yet I'm left with this radical in the denominator. I'm left with a square root 5 that I cannot leave there. So this is where I use the process called rationalizing the denominator. It means to get rid of the radical. Okay? So, let me quiz you for a second.